In 7.4, you're going to feel like you're doing every single thing the same that we did in 7.3. The biggest difference is now instead of us trying to find an unknown side length with trig, with SOHCAHTOA, now we're going to be finding missing angles. And in order to help you realize that we're looking for an angle, we're going to use a different variable, a variable you are not used to. It's the variable theta. It looks like a capital O with a bar that goes right through the middle horizontally. It's a Greek letter. When you see theta, it means this is an unknown angle. We have no idea how many degrees it is. We're going to have to figure it out. So if you're wondering, because I know that I did when I was your age, why didn't they just use x? Why didn't they just use y? It's because x and y were our unknown side lengths, and we wanted to let you know these are unknown angles. We're going to find out how many degrees they are. It's kind of a different way for your mind to work. So just open your brains a little bit, and now you know another Greek letter, okay? Theta. What we're going to be doing is we're going to be finding these missing angles, and when we do, we're going to have to use something we haven't used before, and they are called inverse trig functions. This sine to the -1 is called inverse sine, otherwise known as arc sine. This, with the cosine to the -1, I read it as inverse cosine or arc cosine. I read this as inverse tan or arc tan. It is used to find a missing angle. For example, I told you before that the sine of 30 degrees was equal to 1/2. Well, the opposite of that is true. This is the exact opposite of what I just talked about. The inverse sine of a ratio of 1/2 produces an angle of 30 degrees. You use this on a ratio to figure out what an angle could be. And your calculators have these already set in them for us to figure out how many degrees things are. So, keeping that in mind, now that I'm talking about calculators, we need to make sure our calculators are still in degree mode. Well, the first thing I showed you in 7.3 was, are they in degrees? Is there a little D in the window of your calculator when you're using it? You have to double check that every time you grab a calculator, especially if you're using one in my class. And you go back there, you don't know if the person before you had it in degrees or they're trying to mess with you. And speaking of that, don't be a person who messes with somebody else by switching the mode back there, because you might mess somebody up for their whole test. If everybody leaves it in degrees, we'll be good. But I know that some of you love to press buttons, especially mine, by not writing your name on your paper. So now that I am over that, I really am. I'm working on it. I am going to work on that. We are going to undo trig functions and figure them out using these inverse sines, inverse cosine, inverse tangent. Everything else is going to be the same as what we did in 7.3. We still label OH and A. We still highlight an angle. We still choose the function based off of SOHCAHTOA. But when we're at the very end of the problem, we're going to use inverse trig functions on both sides to figure them out. So, let's start off with what we did. These will be just like numbers 1 through 4 on your worksheet. And then I'll show you the new stuff when we get through 5 through 14. Here's the old stuff. This is number 1 on your worksheet. If you would like to do this with me, you can. They do not give you an angle. They don't tell you if this triangle's A, B, C, or anything. They give you what is the value of each trig ratio, that's a hint to you, in reduced fraction form. They want you to know what is the cosine of the angle in reduced fraction form. So this is old stuff. They start you off with the same stuff you learned in 7.3. We do everything the same. First thing we do is say, well, this must be the angle. They gave us theta, so I highlight the angle. That's step 1. Step 2, we label it O, H, and A. O stands for opposite. I go and I say, which side is opposite? I'm going to put an O right next to this, and there's nothing next to it. I'm not going to really use the O. Then I label H as the hypotenuse. I look at the 90 degree. I go across from it. This must be the hypotenuse. If this is O and this is H, then that must mean this is A. The adjacent, touching the angle, but not the hypotenuse. And what I usually do from here is I say, okay, cosine of theta. The cosine. So, ka, toa. And I realize that the only one that has the A and the H, the cosine, is the A over H. The cosine of theta equals A over H. Which one's A? Which one's H? You plug those in. Is that reduced? No. We have to put it in reduced form. Divide the top by 5, divide the bottom by 5, and you're going to get that the cosine of theta is equal to 4 over 5. That's our answer for number 1. By the way, if they asked you for the sine of theta, you would use the O over H. If they asked you the tangent of theta, you would use the O over A. They just want you to do what we did in 7.3 on the first 4 questions of this worksheet. That's the old stuff. The new stuff starts on number 5. So let's look at number 5, because the next 4 examples that I have for you are, well, what's the new stuff? How do we do it? Find the measure of each angle. Now we got to know how many degrees this thing is. Round to the nearest tenth. And we're going to round. Everything's the same. First step, the angle is theta. We highlight the angle. The second thing we do, we label it O, H, and A. Opposite is this one. I'm going to put an O right next to the 12.5 because that will let me know what the 12.5 is. The H, hypotenuse, it must be 14 units long. I'm going to put the H right next to the 14 so that I know that what I'm using. And then the A, there's nothing next to the A. I'm most likely not going to use it. If I want to figure out what this angle is, I need to use the things that I know to figure out the thing I don't know. I circled the 12.5 in the O and the 14 in the H because that's going to let you know which trig function you need to use. We talked about SOHCAHTOA. Of our 3 trig functions, only one of the 3 trig functions has an O and an H. It can't be ka because that has an A and H. It can't be toa because that has an O and an A. The only one that has the O and H is the SO. And the S stands for sine. So I'm going to write an equation using SO. I'm going to say the sine of this angle, the sine of theta equals the opposite over the hypotenuse, 12.5 over 14. And that is exactly the same thing you did before. There's only one difference. We don't know what this angle is. They want you to figure out what the angle is. The only way to get rid of it is we need to get rid of this sine. We can't divide by it because this is the sine of an angle. We cannot multiply by it. We can't add it. We can't subtract it. That's what we would do with normal computation. This is a trig function. To undo it, we have to use an inverse or an arc. We're going to take the inverse sine of this side and the inverse sine of this side. What you can think of this inverse sine is doing, it's unraveling. It is going to basically make these two things cancel out and turn into 1. And then we have theta by itself. So what are we going to plug into our calculator? We're going to plug this into our calculator. We're going to plug in inverse sine of 12.5 over 14. The inverse sine button is usually right above the sine button. If I see the sine button right there, inverse sine is right above it. I have to press the shift key to get to that sine to the negative 1. So I'm going to punch this in. I'm going to press my shift sine button. You can choose to either do this as the fraction button, 12.5 fraction button, 14. You would have to go to the right and end the parentheses there. Or you can do the inverse sine of 12.5 divided by 14, end of parenthesis. I'm putting that parenthesis in there because some of your calculators will give you an error if you do not put that other parenthesis in the end. So what is my answer? Theta is about equal to 63.2 degrees, and it's about equal to. That's it. It's almost exactly the same, except to unravel sine, we do inverse sine. To unravel cosine, we're going to do inverse cosine. To unravel tangent, we're going to do inverse tangent. Okay, let's do another one. We'll go a little bit faster this time, except number 7. For whatever reason, this 5 is a little tiny 5. It's a little tiny guy. I don't know why. But it's a 5. Here's my angle. O. I don't see anything opposite here. Probably not going to use it. H, right next to the 11. A, right next to the 5. Usually I will circle what I am using. I see an A and an H. And then I have to decide, am I using sine, cosine, or tangent? Cosine. Of what angle? Of angle theta, we don't know what that is equal to the A over H. Now I want to know how many degrees theta is, so I have to get rid of cosine. So in this case, I'm doing the arc cosine, otherwise known as the inverse cosine. Whatever I do to one side of my equation, I do to the other. And then theta will be about equal to whatever the inverse cosine of 5 over 11 is. You have calculators, plug it in. See if you get the same thing as I do. Uh-oh. Nearest tenth. I have to round this up. That makes this go over. Theta is about equal to 63.0. Don't forget, when 9 rounds up to 10, that changes the next place up 1 as well. So 63.0 is this rounded to the nearest tenths place. That's not hard, is it? I have one more for you. It's 9, and then I have the word problem. I decided to do that with you guys too. Let's do 9 real quick. This one will go a lot faster. There's theta. 8 is my opposite. I put an O right next to it. Put my A next to the 14. I decided not to use the H this time because there's no number next to it. I'm not going to use it. I see a OA here. It reminds me of TOA. Tangent of the angle theta is equal to TOA, 8 over 14. You could reduce this if you wanted to because all similar triangles are proportional. You don't have to. Your calculators can do it off of 8 over 14 or anything else. Inverse tan is how we get rid of that tan. it basically undoes the tangent so that you can pop this angle out by itself. But I have to plug in tangent to the -1, otherwise known as inverse tan or arctan of 8/14. And I just want to show you for good measure that if you were to divide by 2 and divide by 2 and get 4/7, you would get the same exact angle for both of these. I'm going to plug this in. 8/14 equals about 29.74 degrees. I'm going to do the same thing, inverse tan of 4 divided by 7, and what do you know, 29.7 degrees as well. It's the same answer because they're in the same proportion, same ratio. My last example for you is a word problem. It's number 15. Jed. Oh, and before I even talk about what Jed is doing, let's talk about the directions for number 15. It says this in the directions: solve the following by either using, Pythagorean theorem. When you get to the word problems, don't forget, hey, we already learned Pythagorean theorem in 7.1. You could use that if you want to. Special right triangles, we learned that in 7.2. Or 7.3, 7.4. So don't just get into the mindset that you have to use trig. You can, but there are other tools available to you like 30, 60, 90, 45, 45, 90, or a squared plus b squared equals c squared. You can decide whatever's easiest for you. Number 15. Jed is building a roof for his shed. The highest point of the roof will be 3 feet higher than the top of the shed. The slanted roof will be 7 feet long. What's the measure of the angle formed by the top of the shed and the slanted roof? This shed. I'm going to draw a shed that you may have seen. I'm not drawing a house shed. I'm drawing a lean-to shed. That means that it's like half of a roof. It's only one pitch. Why do they pitch the roof? So that rain does not sit on top of it, by the way, so that rain will run off of it. It's the only reason houses are pitched. That's how come houses in the desert are flat. In case you ever wondered. They don't have to worry about it. They don't get rain in Arizona. Okay? So now what we have is this shed, and it says he's building a roof for his shed, and the highest point of the roof will be 3 feet higher than the top of the shed. So this must be the top of the shed over here. Top of the shed. Top of the shed. And this point has to be 3 feet higher than the top of the shed. The slanted roof will be 7 feet long. He's wasting some wood. I say that because those of you who've ever been to Home Depot, when they sell sheets of wood, they sell them by 4 by 8 feet sheets of plywood, 4 feet by 8 feet. If he's going 7 feet, he's wasting wood. Look at that. I guess he could use it for another project. But if you're designing one of these and you're thinking about building your own, maybe you should do it in increments of the 4 by 8, right? Just so you think about that kind of stuff. Because someday you might own your own house, and someday, instead of you paying somebody to build your shed, maybe you'll do it yourself. Maybe. I don't know. What is the measure of the angle formed by the top of the shed and the slanted roof? This is what we're trying to find right there. What's this angle? That way we know what to cut the rafters by when we go to our miter saw. This is the kind of math that actually you could use in real life, and it happens in construction all the time. How do we find it? Opposite. Hypotenuse. The sine. Why did I choose sine? Because the only one that has an opposite over hypotenuse, opposite is 3, hypotenuse of 7 is sine, so katoa. Then to get rid of it, and since I want to find the angle, I use this inverse sign to undo it, and my angle needs to be, this is what I punch into my calculator, the inverse sine of 3 over 7. To the nearest, does it say nearest anything? I'm going to go round to the nearest 10th place then. 25.4 degrees. And that's where I'm going to end your notes.